Namaste PU2 aspirants, and I hope that all of you are preparing really hard for your chemistry PU2 final exams. Do not worry, I am there with you, and I hope that you have watched the morning session and have revised all the chemical reactions, name reactions, everything is done. And now it's time to solve questions, and I have brought you almost 50 important questions from these chapters, from all the 5-marker questions of these 5 organic chapters. We will be doing most important questions, and the most important thing is these questions have been taken from your PU2 question bank. I have seen a lot of requests yesterday that ma'am, please solve questions from PU2 question bank, and yes, the link of this PU2 question bank will be provided in our WhatsApp channel. Today it will be uploaded. So if you do not have this question bank, you can download it from our WhatsApp channel, and for that you have to join the WhatsApp channel, and the link of that will be there in the description section of this video. Okay, so students, let's not waste any time. Take your notebook and sit with me and start solving questions. So yes, so section D, we will be having 5-marker questions. Haloalkanes 1 question, alcohols 1 question, aldehydes 2 question, amines 1 questions, and biomolecules 1 question. So there are total 6 questions, and you have to attempt any 4 out of 6. Okay, now coming to next one, haloalkanes and haloarenes. The first question, write any 3 differences between SN1 and SN2 mechanisms. Identify A and B in the given reaction. So SN1, SN2, there are so many differences. You can write any 3. So first of all, you can write this occurs in 2 steps, occurs in 1 step, carbocation intermediate is formed, no intermediate is formed, follows first order kinetics, follows second order kinetics, and many more points also I have given you in my today morning class. SN1, SN2 difference, you can watch there, or you can write these 3 points. Next, coming to here, next coming to identify A and B. So NH2 with Na, NO2 and HCl, what it will give you? It will give you the benzene disonium chloride. Okay, so I will have this one, which is your N2 plus and Cl minus. Next, after that we have bromobenzene. Okay, we want bromobenzene. So for that you can take here Cu and HBr. This is also possible. This is your Gatterman reaction. Or you can also take CuBr, that is your Sandmeyer reaction. Okay, so any one you can take. So that will also give you bromobenzene from benzene disonium chloride. Okay, so this carries 3 marks, this carries 2 marks, and you will get 5 marks. Next, write the mechanism involved in the conversion of 2-bromo 2-methylpropane to 2-methylpropane 2-OL. Which type of solvents favors this type of reactions? And then you have to define these 2 terms. So 3 marks and 2 marks, total 5 marks. So first of all, if I see 2-bromo 2-methylpropane, so I have this one, I have 2-bromo 2-methylpropane to 2-methylpropane 2-OL. Okay, 2-methylpropane 2-OL. So which you have to write the mechanism here. So if I write step number 1, okay, step number 1 will be CH3. Step number 1 is formation of carbocation. Okay, formation of carbocation. So CH3, CH3Br. Okay, and then what happens here, this one goes, and we will get here CH3, CH3 plus. Okay, then step number 2 is formation of carbocation. The step number 2 is attack of nucleophile. Okay, attack of nucleophile. So here what will happen? You have CH3 whole 3 C plus, and then Br minus will attack here, and you will get, sorry, not Br minus, OH minus, right? OH minus will attack here, and this is your slow step. Okay, this is a fast step, so please note down this one also. And then you have CH3 whole 3 OH. Okay, so this carries 2 marks. Then which type of solvent? So it follows, you can write down here SN1 mechanism, right? SN1 mechanism will follow polar or will require polar protic solvent. Okay, polar protic solvent. Next, you have to define enantiomers and racemic mixture. So enantiomers, the stereoisomers that are related as non-superimposable mirror images, are called as enantiomers. And what is racemic mixture? A mixture containing two enantiomers in equal proportions will have zero optical rotation, as the rotation due to one isomer will be cancelled by the rotation of the other. Such a mixture is known as racemic mixture or racemic modification. Okay, clear? Next, question number 3, primary alkyl halide C4H9Br. So we have primary alkyl halide, that is C4H9Br. Okay, this question I have also solved in my previous lecture with alcoholic KOH. Okay, so if you have here alcoholic KOH, it gives you compound B, right? Now compound B is reacted with HBr to give you C. So if you react it with HBr, you give compound C. Now which is an isomer of A. Okay, when A is reacted with sodium metal, okay, when A is reacted with sodium metal, that is your Woods reaction, it gives you compound D, that is C8H18 compound D, which is different from the compound formed when N-butyl bromide is reacted with sodium. Okay, give the structural formula of A and write the equations involved. So we have 3 reactions here and we have to give the structure of A here. So first of all, if you see from C4H9Br, what all primary halides I can have. So I have one primary halides like this, okay, and I can have another like this. These are the 2 primary alkyl halides possible. Now after that what happens, there is one alcoholic KOH will be there, so you will have H and Br will be removed, we will get a double bond here. But now you see here the saying is the C8H18 which is obtained if this N-butyl bromide will react, that is not this C8H18. That means I can say that this A is not this bromine, it has to be this one. So I have guessed the A correctly now. Understood this point what I am saying? See, the point is if this is N-butyl bromide, what product I will get, this product is not that one, it is from some other product. So that means it has to be another primary alkyl halide. So definitely your A will be C4 CH3 CHBr. Let me write it properly, just a minute. Okay, CH3 CHBr, and then we have here I will have CH3 CH2Br. Okay, this is done. Now we have alcoholic KOH. So if I react with alcoholic KOH, okay, here a double bond will be there. Now I will have CH3 CH3 double bond CH2. Okay, next we will have HBr. So if I react it with HBr, so this is your B HBr. So what I will get, CH3 CCH3, then I have CH2H, and you have Br. Okay, so this is your what I will say C. So you can see now A and C are isomer of each other, right? Definitely here bromine is in first carbon, here bromine is in second carbon. Next what is there? You have to write the reaction with sodium metal. Okay, sodium metal, if I react, it will get CH3 whole 2 CH, and then I have CH2, and then again I have CH2 CH and CH3 whole 2. Okay, this is clear. So this one is your D, that is C8H18. Okay, Next, why free radical halogenation of alkanes method is not advised for the preparation of haloalkanes. So from here onwards, these questions have been taken from your question bank. So now, why do we don't have or prefer this halogenation method? I have told you in today's class also, we get multiple products here. We cannot get a single product, so that is why it is not advisable. Next, classify the following into geminal and vicinal dihalides. So just let me just explain once again. Geminal dihalides means on the same carbon you have two X groups. On the vicinal means on the adjacent carbons you have X groups. Okay, geminal is called as alkylidine. Okay, alkylidine, and here it is called as alkylene. Okay, clear? So now what happens is, for vicinal dihalides we need at least two carbons, right? With one carbon we cannot have vicinal dihalides. So you see here ethylene dichloride, it must be two carbons, so this one will be vicinal. Okay, then here only one carbon is there, so it is your geminal. Clear? Next, classify the following as allyl and vinyl. So allyl means, after allyl is this one, you have carbon double bond. In the next carbon if you have X, that is called allyl, and vinyl is when you have X on the same carbon. Okay, so let's so if I have 3-chloropropene, so this one is 3-chloropropene, right? Here I have chlorine group 3-chloropropene, so this is my, I can say this is allyl group. Okay, and if I have 1-chloropropene or 1-chloroethene, so X, the carbon which is having double bond, if that is having X, this is allyl, right? And this is vinyl. So X is attached to the carbon which is having double bond, then this one is your vinyl. Okay, clear? So let's see the answers now quickly. Yes, so you can see free radical halogenation of alkanes leads to the formation of a mixture of mono and polyhalogen compounds. Hence, free radical halogenation of alkanes is not suitable for the preparation of alkyl halides. Next, we have ethylene chloride, that is vicinal dihalides, and methylene chloride, that is geminal dihalide, and allyl and vinyl I have already discussed. Okay, now let's move to the next question here. So that is, write the product obtained when ethyl bromide reacts with KCN and with AgNO2. What is Grignard reagent? Write its general formula, complete the following reaction, and name the reaction, complete the following reaction. Okay, so I have given such name reaction questions so that we can practice the reactions a bit. Okay, so first of all, you have this one. So if you have ethyl chloride, ethyl bromide with KCN, so that will give you ethyl cyanide. With AgNO2 you will get nitroethane. Next, what is Grignard reagent? RMgX. Complete the following reaction. So this is what? C6H5Br plus CH3Br Na dry ether X. So this is nothing but your Woods-Wittig reaction. You will get C6H5 and CH3 here. Complete the following reaction. Here this is, yes, this is a very good question. So remember, whenever we have RMgX, please note down this one, plus R dash ONA, okay, then the product here will be RR dash. Okay, so we will combine these two, that will be the product. And CH3Br plus KNO2, AgNO2 will add nitro group, but KNO2 will add ONO group. So you will get CH3ONO. Okay, so let me show you the answers here. Okay, just a minute. Yes, so you can see first one you will get C2H5Cn, then you will get C2H5NO2. When alkyl halide is treated with magnesium in dry ether as the solvent, it gives alkyl magnesium halide. This is known as Grignard reagent. Next, it is denoted as RMgX. You also have to write the general formula, so RMgX. The next one, if I write, okay, so what I have to write, complete the following reaction. So if I just want to write the product of this reaction, I hope it is visible. So I have here C6H5Br plus CH3Br, okay, it gives me Na dry ether, Na dry ether, it will give me C6H5CH3. Okay, so this one is your product, and the name of this reaction is Woods-Wittig reaction. Oates-Fittig reaction. Okay. Next we have here the product, as I say, it will be RR. So C6H5 and C2H5. I have written by mistake C6. So it's C6H5, C2H5. Okay. Next we have here KNO2. It will add ONO. So you will get CH3ONO. Okay. You can see here. Next we'll move to question number 6 here. Although chlorine is an electron withdrawing group, yet it is ortho-para directing in electrophilic aromatic substitutions. Why? So this is very easy question. So generally if you see, chlorine is having lone pair, right? So it donates electron to the ring, and the ring density increases, or the electron density in the ring increases as at ortho and para position. So that is why the substituents are attached at ortho and para position. Next, identify the reactant. So you can see here A is, you can see this is a Oates reaction. You can see the same part is repeated. So this must be tertiary butyl bromide. You can take any, bromine is there, so we should take bromine here. Then this is your phosgene reaction. So it is CHCl3 chloroform with oxygen reacts in presence of HNu to give you COCl2 and HCl. This is a dangerous gas, that is phosgene, right? So that is why chloroform should always be stored in the dark. This also can be a question, so remember this one. With the help of a chemical reaction, show that presence of electron withdrawing group fastens the nucleophilic substitution reaction. So this is, you can see, when you take only chlorobenzene and sodium hydroxide, you require very high temperature and pressure. But if you add 3 nitro groups, the same reaction can be done with the warm water. In the warm conditions also the reactions can happen. Name the reaction involved in the preparation of Freon 12 and from tetrachloromethane, and mention one use. So the Schwartz reaction is used, and use of Freons, it is used in refrigerators and in air conditioners, right? So you can see here, chlorine is an electron withdrawing group, yet it is ortho-para directing. This is because chlorine exhibits positive mesomeric effect, means plus R effect or plus M effect. By resonance, chlorine tends to stabilize the carbocation and increases the electron density at ortho and para position. So now if you see, I just want to draw in rough and show you. See, if I draw the resonating structures of chlorine, chlorobenzene, you can see. Okay, this is Cl, here we have lone pair, this comes here, this comes here. So what I will get? I will get a structure like this. Okay, next this one will come here, this one will come here. So I will get a structure like this. Okay, and then we will have this one here and this one here. Okay, and then we will get a structure like this. Okay, and then we have this one and this one. So we will get and Cl here. Okay, so you can see that if I draw the resonating structures of chlorine, the charge electron density is increasing at ortho and para position only, right? So that is why, even though it is plus minus I effect, but due to plus R effect, the charge density is higher at ortho para position. So that is why it is ortho para directing. Okay, next identify the reactant. So here it is CH3 whole 3, CBr will be the reactant. Cl you cannot take, you have to take Br only. Why? Because you can see in the byproduct it is bromine, right? So this has to be bromine. Then this one is chloroform. I already tell you, phosgene reaction, that is there. Next, show the presence of electron withdrawing group increases the rate of the reaction. So this also you can write down the reaction here. So if I have chlorobenzene with 3 nitro groups, okay, and you take NaOH, then within warm conditions you will get OH replaced here. Here NO2 groups are there. So this shows that at when we have higher more number of electron withdrawing groups, NaOH can easily be substituted, or OH minus can easily replace the chlorine atoms, which was not possible if this NO2 is not there. If NO2 is not there, we need almost 623 Kelvin and 300 atm pressure. Okay. Next we have name the reaction. So here it is Schwartz reaction, and where it is used in your refrigeration and air condition. Next we have write any 3 reasons why haloarenes are less reactive towards nucleophilic substitution reaction. This question can be asked in variety of ways, like why SOCl2 cannot be used to prepare chlorobenzene, or why haloarenes are less reactive towards nucleophilic substitution reaction. Any such type of regarding haloarenes question comes, there are 3 reasons. The first one is the partial double bond character, second one is the sp2 hybridization of the carbon, and the third one is the unstable phenyl cation formed. Okay, so you can see these 3 reasons are there. Okay, next, with the help of resonating structures shows that the presence of the nitro group on meta positions does not affect the reactivity of haloarenes for nucleophilic reactions. So I just want to explain this one here. See, just now I draw the see, if you have X group here and nitro group here. Okay, now suppose one nucleophile wants to attack the ring. Okay, then what will happen? How can I draw? So what should be the condition? When can this attack take place? See, please understand carefully. See, if the ring density, see, this is already a nucleophile, okay, because of the lone pairs present here, which is donating the electrons to the ring, and also because of this pi bond, the loose electrons are present. So now what happens, if this NO2 group is present, if it is able to take the electrons of this, or somehow if it is able to take the electrons from the ring, then only we can say that it is reducing the electron density and increasing the electrophilicity, so that a nucleophile can attack. So the charge should go towards NO2 group, right? So now if I see in the ortho position, you can see this bond will come here, this bond will come here. So what I will get here in the first one, I'll draw like this. This will be X plus, and here I will get N. Okay, if this bond comes here, this bond will go here. So I will get O minus and O minus. Next, again this bond can come here. Okay, this is not like this, sorry. Then this bond, okay. Now this bond, so you can see that NO2 group has taken the electron density. This group comes here, this group comes here, and this one comes here, right? So now we have like this X plus, okay, just a minute. So now if you see this, if I draw the next resonating structure, what I will get here, I will get like this. Okay, just a minute. So this bond comes here, this bond shifts here, so this bond comes here. So we, just a minute, I'll do here this one structure again. So basically what I can want to say is, if it is present in ortho position, we can see that nitro group is taking the charge, right? So you have this X plus, and you have this one, you have this one, you have N, O and O. So you can see that the nitro group is taking the charge from the ring. Now if I do in the meta position, okay, if I do in the meta position, if I find this NO2 group at the meta position, one second, what happened, pen, okay. So now if I see that you have this X group and you have this N double bond O, O and this one, okay. So now we have like this, and this bond will shift here, and then we have this one, and here we have this one, okay. Now I have the rest of the structures like this, okay. Then we have this one, and now you see after this one comes, we get a structure like this here, okay. So you can see, I will draw like this. Okay, so here you can see that the negative charge is not taken by the NO2 group. So I can say that it is not withdrawing the electron density from the ring. Okay, so that is why here what we will happen. So NO2 group, if it is present in the meta position, then it doesn't affect the reactivity of the haloarenes. It does not reduces the electron richness, and the nucleophile will not attack if the NO2 group is in the meta position. Okay, so the nucleophile can attack only if the NO2 group is present in the ortho and para position. So that you can see here, resonating structures are given, the same thing which we have drawn, it is given here, right? Okay, now we'll go to next question number 9. Primary alkyl halide C4H9Br reacted with alcoholic KOH to give a compound B. Compound B is reacted with HBr to give compound C, which is an isomer of A. Write the structures of A, B and C. So we have just done a similar question, right? C4H9Br. So primary alkyl halide I can take like this, CH3, CH2, then I have CH2, CH2 and Br. Okay, now what will happen? This is suppose A. Now if you treat it with alcoholic KOH, then we have CH3, CH2 and here we have CH double bond CH2. Next here we have HBr. Now HBr, what it will do? You will have CH3, CH2, CHBr and CH3. Okay, so you will find the structure of A, B and C like this. Okay, clear? Now we have to define the following: Schwarz reaction, Finkelstein reaction and Wurtz reaction. Sorry, here spelling mistake. So these are important questions. So Schwarz reaction is used, all of you will be knowing, for the preparation of this one is your Schwarz reaction for the preparation of fluoroalkanes. Next we have definition is very same. Next we have Finkelstein reaction, so for the preparation of iodoalkanes, and then we have Wurtz reaction for the preparation of hydrocarbons. Okay, so if I just want to write this reaction example, so you have suppose CH3Cl, okay, plus NaI dry acetone, it will give me CH3I plus NaCl. Okay. Next we have Wurtz reaction. Alkyl halides when treated with sodium in dry ether give compounds where two alkyl groups are joined together. It is called Wurtz reaction. Okay. So now you have, for example, 2 CH3Cl and then we have sodium dry ether. Okay. This will give you CH3 plus 2 NaCl. Clear? Okay. Now we'll see question number 10. Compound M with formula C3H6 on reaction with HBr forms a compound N, and N on heating with sodium metal in dry ether produces X. Write the IUPAC name of M, N and X. So we have here C3H6, for example. We have C3H6. So I have CH3, CH double bond CH2. Okay. Then we have here treatment with HBr, and that will give me this one as bromine. Okay. So this is what? This is M. Okay. Next we have here N, okay, and then it is treated with sodium and metal. Okay, so this one will give you CH3, CH, CH3, CH, CH3 and CH3. Okay, so this is your reactions which will give you M, N and X. Okay. Next, complete the following reaction sequence. So C6H6 with Br2 will give you FeBr3. So you will have this bromine with this one. Then Mg dry ether, you will get MgBr. Okay. Then when you treat it with RNH2, this MgBr will be replaced with H. Okay, so that will be the product formed. Next we'll go to next chapter, that is alcohols, phenols and ethers. The first one here. So there in this chapter we have three mechanisms. All the three mechanisms are very, very important. So first one is the mechanism of dehydration of ethanol to ethene. Okay, dehydration of ethanol to ethene, and you have to identify A and B in the following equation. So if you see here, this one will become, this is your Kolb's reaction, we will get OH and COOH, that is salicylic acid. Next we have this one and HI. So here you can see that this is your cleavage of your ethers. This bond will break because here tertiary side is there. So here a carbocation will form, I will attack on this side. So I will get CH3 whole 3 Ci. Okay. Now moving to the next one. So here I am giving you the mechanism for the protonation of alcohols to alcohols, right? Sorry, for the conversion of alcohols to alkenes. So first of all, in the first step there is protonation of alcohol. In the second step there is formation of carbocation, and in the third step there is a H releases here. We get an alkene, and then there is a H plus produced here. Okay. Fine. Next we'll see question number 2. Identify A, B and C in the following reaction. So we have OH and then bromine and water. Bromine and water will give you 2,4,6 tribromo compound. So I will get the product like this, that is OH, and we will have bromine, bromine and bromine, right? Next, phenol with zinc. So if you have bromine in CS2, then you will get only monobromo product, but bromine water will give you tribromo derivative. So please remember this one. Zinc and phenol will give you benzene. Then C2H5 OH plus Na gives C2H5O Na plus gas will be released, that is your hydrogen gas. Now how to prepare phenol from aniline? Okay, so this is also very simple one. So you have to treat the phenol is first converted, first aniline is converted to benzene diazonium chloride, then benzene diazonium chloride is reacted with warm water to give you phenol. Okay, so diazonium salts are hydrolyzed to phenols by warming with water or by treating it with dilute acids. Okay, now we will move to next question number 3. Explain the mechanism of dehydration of alcohols to ether. Okay, and how anisole react with acetyl chloride. So here we have this one. First one, the first step is very similar. First of all, this OH gets, this is answer 3, okay, 3. So first of all, OH gets protonated, O plus H2 is formed. Next, another alcohol attacks on this one and this O plus H2 is removed. So CH3, CH2, O plus H, CH2, CH3 plus water is formed, and then from here there is deprotonation, and then deprotonation takes place, we get ether plus H plus. Okay. Next question number is how anisole reacts with acetyl chloride. So anisole means benzene with OCH3 group. Okay, acetyl chloride CH3Cl, this is Friedel-Crafts alkylation. Now OCH3 is an electron donating group, so the substituents will be attached at ortho and para position. So what product I will get? Can see here, anisole undergoes Friedel-Crafts acylation reaction where acyl groups are introduced at ortho and para position. So you can see OCH3, CH3COCl, AlCl3, then at ortho and para position the substitution will take place. Next we have question number 4 here, mechanism of hydration of alkenes to alcohols. Then complete the following reaction. So similarly, alkenes to alcohols, what will be the mechanism? You can see here, first of all, this water gets protonated to give you H3O plus. Okay, then alkenes react on this H and water is removed and we get a carbocation here, right? The first step is the formation of carbocation. Then we have O plus H, OH2O. This one reacts here and carbon plus is formed, so we will get O plus H2. Means this one is attacking on this one, so this group is attached to this carbon. Now after this what happens? Deprotonation to form an alcohol. So we have this water group here, this one attacks on this H, okay, and then this double bond comes here and we get an alcohol here and H3O plus. Okay, now coming to the next one, this reaction if I want to first do, so H2 and H plus will add water following Markovnikov's rule. Okay, next we have CrO3, this is A. CrO3 is a very good oxidizing agent, it will convert secondary alcohols to ketones. So what I will get? CH3, C double bond O, CH3. Okay, next we will see question number 5. An alkene X, that is C3H6, reacts with H2O and H plus to give compound Y. Now compound Y further undergoes reaction with the CrO3H2SO4 to produce compound Z. Write the IUPAC name of the compounds X, Y and Z. Okay, so if you see here, first of all if I take C3H6, okay, you have C3H6. So that is CH3, CH double bond, CH2. Okay, reacts with H2O and H plus to give compound Y. H2O and H plus to give compound Y. So that will be this one. Okay, compound Y. Next, it reacts with CrO3 and H2SO4 to produce compound Z. So you have CrO3 and H2SO4 to produce compound Z. Okay. Okay, next what we have, write the IUPAC name of X, Y and Z. So which is your X? So this is X, which name is propene. Okay, then Y is propane 2OL. Okay, then Z is propanone. Okay, next write among the following compounds having the lowest and the highest pKa value. Now see, lowest pKa value means highest acidic, right? Highest acidic. So if we have electron withdrawing groups, then it will be more acidic. So we have para-nitrophenols, phenols, ethanol and orthocresol. So it has to be para-nitrophenol. So highest acidic will be para-nitrophenol. Okay, next we have highest pKa value. Okay, highest pKa value means again it will be lowest acidic. Okay, highest pKa value means lowest acidic compound. So lowest acidic, you can see that phenols are generally more acidic because of the stability of the conjugate base. So this is phenol, this is also phenol, and this is orthocresol means also you have OH and CH3. So ethanol is the least acidic here because it is an aliphatic one. So it will have the highest pKa value. Okay, next question here. Number 6, how is phenol prepared from benzene sulfonic acid? Write the equation. How anisole reacts with methyl chloride, and then what is the effect of electron donating group on the acidity? Okay, so first of all, how this is prepared from benzene sulfonic acid. So first you have to take benzene, oleum, you will get benzene sulfonic acid, and then you treat it with NaOH and H plus, and you will get OH here. Okay, that's the first thing. Next, how anisole reacts with methyl chloride. So if you see here, yes, so anisole reacts with Friedel-Crafts as alkylation, CH3Cl. Again, as I told you, it is ortho-para directing group. So you will get CH3 at the ortho and para position. Next, what is the effect of electron donating group? So So electron donating group, always remember, electron donating group will decrease the acidity. Decrease the acidity. Okay, electron donating group will decrease the acidity and electron withdrawing group will always increase the acidity. Okay, Next we'll see question number 7 here. What are vinyl alcohols? Give an example. What are allylic alcohols? Give an example. Benzylic alcohols, symmetrical ethers, unsymmetrical ethers. Give an example. So any of these can be asked in your 2-marker questions or in the 5-marker questions, any sub part. So we will quickly see. As I told you, vinyl alcohol means what? You have C double bond C, and on that double bonded carbon you have OH. Allylic means what? You have C double bond C, and the next carbon you are having OH. Then benzylic means what? You have a benzene ring, carbon attached, and to the next carbon. The carbon not directly to the benzene ring, but to a carbon which is attached to benzene ring, OH is attached. Symmetrical ethers means if you have ROR, means both the sides are same group. And unsymmetrical ether means ROR dash. Okay, so we will see here examples. So vinyl alcohols are compounds containing a hydroxyl group attached to a carbon atom that is double bonded to another carbon atom. Okay, now example is vinyl alcohol. Similarly, allylic alcohols are the compounds where the hydroxyl group is attached to a carbon atom that is adjacent to a carbon-carbon double bond. Next, this is your allylic alcohol. Benzylic compounds are those where the hydroxyl group is attached to a carbon atom that is directly attached to the benzene ring. Okay, so the carbon atom should be directly attached to the benzene ring. To that carbon, if any OH group is attached, then that is your benzylic alcohol. Symmetrical ethers, when you have same groups attached on the both the sides of the R. Unsymmetrical means when you have different groups attached on both sides of the R. Okay. Next question we have here, question number 8. Give the structure and IUPAC name of the products expected from the following reaction. You have catalytic reduction of butanol. So butanol, when it is reduced, you will get butanol. Okay. Next you have reaction of propanol with methyl magnesium bromide followed by hydrolysis. So I want to draw this reaction and show you. So if you have propanol, okay, just let me draw here. Propanol is like this, okay, and you are reacting it with what? Methyl magnesium bromide, that is MgBr, and I have CH3. Okay, so this is minus, this is plus, this is minus, this is plus. So this one will attack on this one, this bond will shift here, and this one will take MgBr. So initially I will get CH3, CO, MgBr, then I have CH3, and then I have CH3. Then after that, if I do hydrolysis, what will happen? This OMgBr will get converted to OH. So what I will get? 2-methyl propane 2-OL. Okay, so that is 2-methyl propane 2-OL. Next, how the tert butyl alcohol reacts with aluminium. Okay, so we know that alcohols can react with metals, right? So that is, you can see it forms aluminium tert butoxide. So what will happen here? OH will be released, aluminium will be replaced here. So you will get a complex, not a complex, but a salt like this, aluminium tert butoxide. Okay, and you will get hydrogen gas produced. Next is name the product formed when phenol is treated with acidified solution of Na2Cr2O7. Write the chemical equation. So this one is for this one. Okay, just do not get confused. I'll write the benzoquinone. So the product formed when phenol is treated with K2Cr2O7. So we have like this K2Cr2O7, and that one will give you benzoquinone. Okay, clear? Next, question number 9 here. Among alcohols and phenols, which is more acidic and why? Phenols are more acidic because their conjugate base is more stable due to resonance. Explain the preparation of phenol from cumene. Yes, this is very important question. So first of all, phenols are more acidic. This is because the phenoxide ion which is formed is more stable from the ionization of phenol, is stabilized by resonance. Okay, alcohols there is no such stability, but in phenoxide ion there is stability due to resonance. Then cumene, how does it happens? Cumene is oxidized in the presence of O2 to give cumene hyperperoxide. It is then converted to phenols and acetone by treating it with dilute acid. Okay. Next, question number 10. How do you prepare aspirin from salicylic acid? And write the chemical equation and deduce its IUPAC name for aspirin. So aspirin is a drug or medical thing which is used in medicines. So when you take salicylic acid and you react with when you do acylation of salicylic acid, we get aspirin. Okay, you can see the reaction like this. Yes, so this is your salicylic acid, and when you do acylation by using anhydride, this OCOCH3 is formed here, and this plus one acid is formed. This is your aspirin, and what is its IUPAC name? 2-acetoxybenzoic acid. So this is 1, this is 2, 2-acetoxybenzoic acid. Next, what is the effect of electron withdrawing group on the acidity of phenols? So for electron withdrawing groups such as NO2 group or Cl2 group, they stabilize the phenoxide ion formed after deprotonation, thus increases the acidity of the phenols. What is the effect of electron donating group? For electronic donating groups such as OH, OCH3, they destabilize the phenoxide ion, leading to decreased acidity of the phenol. So electron withdrawing group will increase, electron donating group will decrease. Next, boiling point of alcohols on increasing the number of carbon atoms. As the number of carbon atoms in alcohol increases, their boiling point rises due to the enhanced van der Waals forces. So van der Waals forces is dependent on the mass, right? So more is the mass, more will be the hydrogen bonding, more will be the intermolecular forces, and higher will be the boiling point. But if branching increases, then the boiling point will decrease. Okay. Next, we'll go to next chapter, that is aldehydes. Okay, I have some more name reactions from this chapter that you should be, yes. So can you guess this is which one? So I want you to remember this Riemer-Tiemann reaction where salicylic aldehyde is formed. How it is formed? You have to take here phenol, react with CHCl3 and NaOH, we get this intermediate, and after that treating it with NaOH, and then finally we get salicylic aldehyde. Next we have here Coles reaction, Coles reaction. So you have OH, and if you treat it with NaOH you get O minus Na plus, then you treat it with carbon dioxide, you will get 2-hydroxybenzoic acid, which is called as salicylic acid. Next, Williamson ether synthesis. So in Williamson ether synthesis we have very simple mechanism. You have one haloalkane and you have one alkoxide. Okay, now this one will react with this one, so we will get here R-OR. Okay. Next is, this is your Williamson ether synthesis. Next we will go to aldehydes, ketones and carboxylic acid, third chapter. Okay, here also mainly the questions will be from the reactions. So first one, give the IUPAC name of this compound and explain Gatterman-Koch reaction. So IUPAC name, I think you all can write. This is 2 carbon, so its IUPAC name will be ethanol, right? No doubt. Here you can see 1, 2, 3. 3 carbons are there, and on the second carbon there is a double bond, so you have prop 2-ENAL. Next, here we have ester, so you can see here I have 2 carbons and here I have 2 carbons, so you can write down as ethyl ethanoate. Okay, both the sides same carbons are there, so we can write down ethyl ethanoate. Next, what is Gatterman-Koch reaction? Gatterman-Koch reaction is also for the preparation of benzaldehyde. You take benzene, you react with carbon monoxide in the presence of AlCl3 and you get here benzaldehyde. Okay, so you can see here benzene reacts with carbon monoxide and hydrogen chloride in the presence of anhydrous AlCl3 and traces of copper chloride to give benzaldehyde. Okay, so what will be the reaction here? You have benzene ring, COHCl, anhydrous AlCl3 and copper chloride, that will give you benzaldehyde. Okay. Next, question number 2 here, write the equations for the reactions between carboxylic acid and PCl5, reactions between formaldehyde and concentrated NaOH, formation of oxime from carbonyl compound, and then among formic acid and acetic acid, which is more acidic and why. Okay, so these reactions, very simple reactions. What happens here? First one, if I write 2, 1, okay, see. You have RCOOH, okay, and if you are reacting it with PCl5, So OH will be replaced with Cl. Okay. Next, second one is the reactions between formaldehyde and concentrated. So you have formaldehyde and concentrated NaOH. So you will get here HCH2OH. Okay. Then you have HCOO minus and Na plus. Next, third one here is we have formation of oxime from carbonyl compounds. Okay, so you have carbonyl compounds and we have oxime here. Okay, so what will happen? This bond will go and you have this one. Okay, next B is what? Among formic acid and acetic acid, which is more acidic, give reason. So obviously formic acid is more acidic here. Why? Because the conjugate base that is formed here is more stable, whereas in acetic acid the conjugate base which is formed is destabilized due to the plus R effect or plus I effect or due to inductive effect. So like for example, if you see formic acid, we will get this conjugate base, right, and this is a stable one. But if I see acetic acid, the conjugate base is like this. Now this CH3 group can donate electrons to this carbon and the electron density will increase, and that is why the stability will decrease. But here there is no such effect, right? So that you can see here. Formic acid is more acidic because the conjugate base is more stable than the acetate ion. Why it is more stable? Because of the absence of any electron donating or plus I effect. Next, we will see question number 3. Explain the preparation of carboxylic acid from Grignard reagent and give equation. Explain HBZ reaction with example. So what happens when you take Grignard reagent? Okay, if Grignard reagent reacts with carbon dioxide, we get carboxylic acid. We have to write the equation for that. Next, what is HBZ reaction with an example? So whenever alpha halo acids are formed in the presence of X2 and red phosphorus, we call it HBZ reaction. Okay, so let us quickly see this one. So first of all, Grignard reagents react with carbon dioxide to form salts of carboxylic acid, which gives carboxylic acid after acidification with mineral acids. Next, you can see here HBZ reaction, carboxylic acids containing alpha hydrogen. So actually this is B part, okay, and this is A. Yes, carboxylic acid containing alpha hydrogen reacts with Cl2 or Br2 in presence of small quantities of red phosphorus to give you alpha halo acid. So RCH2COH, X2 red phosphorus, you can see here alpha carbon, the carbon next to the COOH group. Alpha carbon will have an alpha hydrogen. This alpha hydrogen is replaced with X in presence of red phosphorus. So we will get this one as X. Next, we have here, okay, I didn't write the reaction for this one. Let me write down. So if you have RMgX, okay, then you have C double bond O, O2, okay. Next, R minus, this one plus, this one comes here, this one comes here, and we'll get here like this a structure, that is R C double bond O, O minus MgX, and then in presence of H3O plus we get OH. So it will be R C double bond O, OH. Okay, so that is how you can produce carboxylic acid using Grignard reagent and carbon dioxide. Next, we have question number 4. Write the general equation involved in the addition of ammonia and its derivative to the carbonyl group. Explain Cannizzaro reaction. Aromatic aldehydes do not answer to Fehling solutions test. Okay, so these are the things that you have to answer. So first of all, general mechanism of the addition of ammonia to the carbon derivative. So you can see here that this N is a what I'll say nucleophile, right? So what happens? This one is a nucleophile, this is electrophile, this one attacks on this one, this bond shifts here. Okay, so we get an intermediate where this NHZ is attached here, O minus is formed, and that O minus takes a proton from here and OH is formed. Okay, so after that there is a rearrangement where our final product we get is C double bond NZ, or a imine is produced. Next, Cannizzaro reaction. So aldehydes which do not have an alpha hydrogen atom undergo self oxidation and reduction on heating with concentrated alkali, concentrated NaOH. In this reaction, one more molecule of aldehyde is reduced to alcohols while another molecule is oxidized to carboxylic acid. So you can see here, for example, formaldehyde is taken, right? This is in presence of concentrated NaOH. What will happen? Formaldehyde will get oxidized to give you salt of formaldehyde, sorry, not formaldehyde, benzaldehyde, and this one will be reduced to give you alcohol, okay, and the reagent is concentrated NaOH here, okay. Next, aromatic aldehydes do not answer to Fehling solution. Why? So basically what happens is, when you take Fehling solution, okay, you give alkaline medium, and you just studied that Cannizzaro reaction takes place in this alkaline medium. So when there is no alpha hydrogen and you are providing alkaline medium, so instead of undergoing Fehling's reaction, the compound undergoes Cannizzaro reaction, okay. So aromatic aldehydes undergo Cannizzaro reaction due to the absence of the alpha hydrogen in the presence of alkali medium, hence they do not undergo Fehling's solution or Fehling's reaction, okay. You cannot find the red precipitate there, okay. Next, we'll move to question number 5. With respect to the structure of carbonyl group, give the following information: hybridization, sigma and pi bond, geometry and bond angle. So if you see, C double bond O is like this, right? So what will be the hybridization? We have 3 sigma bonds, so the hybridization is sp2. Sigma and pi bonds, we have 3 sigma bonds and 1 pi bond. Geometry is trigonal planar and bond angle is 120 degree, okay. So you can see here. Next, explain the conversion of toluene to benzaldehyde by side chain chlorination. So toluene you take, just treat it with chlorine and H nu. The toluene gets converted to CHCl2, then you convert it into water and 373 Kelvin. So you will get the benzaldehyde, okay. So you can see here, side chain chlorination of toluene gives you benzyl chloride. Please remember the name of this structure, that is benzyl chloride, on which on hydrolysis gives you benzaldehyde, okay. Next, question number 6, write the chemical reactions to affect the following transformation: butane 1-OL2 butanoic acid. So you can see primary alcohol to acid, so it is your alkaline KMnO4. Cyclohexene to hexane 1,6-dioic acid, so this also alkaline KMnO4 can break the double bonds and can give you dioic acids. Butanal to butanoic acid, aldehydes to acids, that can happen with your Tollens reagent, Fehling's reagent you can use. So you can, let's take Tollens reagent, okay. So okay, just a minute, okay. So let me write down the answers here. 6-1 will be butane 1-OL2 butanoic acid, right? So CH3 CH2 CH2OH2 CH3 CH2 CH2 COOH, okay. So here we have what is it? Yes, transition will be from alkaline KMnO4, okay. Next, cyclohexene, okay, to hexane dioic acid, COOH CH24 and then COOH. So this is also alkaline KMnO4, okay. Next, third one is butanal to butanoic acid. So if I have like this CH3 CH2 CH2 COH, okay, butanal to butanoic acid, it is CH3 CH2 butanoic acid, COOH. So here what will happen, this butanal group is converted to butanoic acid and we require any reagent like Tollens reagent AgNH3 whole 4 2 plus we can use, okay, Tollens reagent. Next, Clemmensen reduction with an example. So carbonyl compounds can be reduced to hydrocarbons using the reagent zinc, mercury and amalgam. Zinc, mercury, amalgam and HCl. So you can see this carbonyl compound is reduced to hydrocarbon, that is your Clemmensen reduction. So you also prepare for Ulf-Kirchner like this. Next, explain the test to distinguish between aldehydes and ketones. Tollens test, aldehydes will show positive Tollens test, Fehling solution, ketones will show negative Tollens test. Complete the following. So here there is simple acylation, CH3COCl anhydrous AlCl3. So you can find this one like this, you will get COCH3. Then you have NH2OH, here H2O will be removed. So we have CH3 to C. Then I have double bond NOH. Okay, clear? Next, among 4-nitrobenzoic acid and 4-methoxybenzoic acid, which is more acidic? So 4-nitrobenzoic acid will be more acidic. Why? Because it has an electron withdrawing group. So whenever we have electron withdrawing group, the acidity will increase. For electron donating group, the acidity will decrease. Okay. Next, you can see here the test that I have given. Yes. So first of all, tolerance test. Aldehydes on treating with tolerance reagent gives a bright silver mirror due to the formation of silver. You can see here. Okay, I did a mistake. I think here the formula of tolerance reagent, it is NH3 2. Okay. Yes. Okay. Next, this one. So nitrobenzoic acid is more acidic because the presence of electron withdrawing group will stabilize the conjugate base. 4-methoxybenzoic acid has electron donating group. So please write down the full formula in their answer sheet, not like this EWG, EDG, don't write like that in the exam, which stabilizes the conjugate base and hence it is less acidic. Okay. Next, we will see, we have to fill the reactions. So you have here Mg and NO2. So what will happen? MgBr will form here first. So I can write here MgBr. Then COO group, carbon dioxide. So this one will attack on this one and you will get like this. That is C double bond O, O minus MgX. Okay. Then on hydrolysis, what happened? On hydrolysis, we will have, this is COOH group. Okay. Next, arrange the following aromatic carboxylic acids in the increasing order of their acidity. So if you see acidity order, here there is an electron withdrawing group, here it is a donating group. Withdrawing group will have more acidity. So if I write like this, okay, you have to write in the increasing order, means least acidic. Donating group will have the least acidic. So 3 will be the least one. Then where there is no group, and the highest one will be this one, NO2 group, where we have COOH. Okay. Next, we have what is the haloform reaction, given example. What is aldol condensation, given example. Name the product formed when formaldehyde undergoes Clemmensen reduction. Okay, haloform reaction. So what is haloform reaction? So if you see, if I have this CH3CO group, okay, and here anything is present, I don't care, this group should be there, and if I treat it with NaOI or NaOX, or you can write it like X2NaOH. Okay, then what happens? This part gets oxidized to an acid group. Okay, so what I will get? Sorry, this part breaks to give you an haloform, that is CHX3, and the rest part gets oxidized to an acid, that is RC double bond O, O minus and Na plus. Clear? So this is very important and it is used for different distinguishing also, but the main thing that you have to keep in mind is this CH3CO group should be there. Okay, so now let us see what is haloform reaction. So aldehydes and ketones with at least one methyl keto group. So this is your methyl keto. You can see one methyl and one keto group, right? Are oxidized by sodium hypohalite. So what is sodium hypohalite? This NaOX is called as sodium hypohalite, or it can be also written in the form of X2/NaOH. Okay. To sodium salt of carboxylic acid with one carbon less than the parent carbon. So you can see here, because this bond is breaking, right, this carbon is forming this haloform compound. So this group RC double bond O, this one we are getting a salt of carboxylic acid, but one carbon less than the parent compound. Okay, the methyl group is converted to haloform. Clear? Now we have this RCOCH3, NaOX is there, and we'll get RC double bond O, O minus Na plus, and then we have CHX3. Next, what is aldol condensation, and then give an example. So aldol condensation, we all know what is aldol condensation. aldehydes and ketones with at least one alpha hydrogen. Okay, remember in Cannizzaro reaction there should not be any alpha hydrogen, but in aldol condensation we need at least one alpha hydrogen, undergoes self condensation in the presence of dilute alkali to form beta hydroxyaldehyde or ketone. So initially a beta hydroxyaldehyde or ketone is formed. After that, on heating it undergoes dehydration to give you alpha beta unsaturated aldehydes or ketones. Okay, next let me erase. Yeah, next is name the product formed when formaldehyde. So this is your formaldehyde. Okay, formaldehyde undergoes Clemmensen reduction, so this one will get converted to H2, so you will get CH4, and that is nothing but methane. Okay, so I have written here this answer as wrong, and it is CH4, that is methane. Okay, next, an organic compound X with molecular formula C8H8O forms an orange precipitate with 2,4-DNP reagent and gives yellow precipitate on heating with iodine in the presence of NaOH. So now if it is reacting with 2,4-DNP means it has to be aldehydes or ketones. It is reacting with iodine in the presence of NaOH. Just now we discussed haloform reaction, so it is having CH3CO group. It neither reduces tolerance reagent, means it is not an aldehyde, it has to be a ketone, and does not decolorize the bromine water. On oxidation with chromic acid, X gives a dicarboxylic acid, okay, having molecular formula C7H6O2. Okay, on oxidation with chromic acid, it gives a X gives a carboxylic acid Y having the molecular formula of C7H6O2. Identify the compound X and Y and write all the reactions involved. Okay, so let us see here. So if I have on reaction, it gives a carboxylic acid Y having the molecular formula C7H6O2. So I think here a small error in the question, this is C7H8O. Okay, so let us see now. If I have this structure, fine, once again, this is correct only. Okay, so what happens, you can see, you have, suppose this is 6 carbon is there, then I have 7th carbon, and then I have 8th carbon. Okay, this is the structure of an organic compound X. Okay, with molecular formula C8H8O. So you can see 1, 2, 3, 4, 5, 6, 7, 8, then 6, 7, 8, and then oxygen. Reacts with 2,4-DNP and gives a yellow precipitate. It will give yellow precipitate definitely. So if I want to react, write down all the reactions of this one first. So I have this one. When it is reacting it with 2,4-DNP, okay, so we have like this. You have here H2N, okay, and then 2,4-DNP. Okay, so what will happen? This group will be removed and we will get a product here like this, CH3 double bond N, then you have like this, and you have here NO2 group and here NO2 group. Okay, so please put down the NO2 groups here. The second one is gives yellow precipitate with iodine. So if I react it with I2 and NaOH, so what will happen? This one will break like this. See, it will become like this. You will get COO minus Na plus, and you have CHI3. Okay, then it neither reduces tolerance, there is no reaction here. On oxidation with chromic acid, so if I just chromic acid, if I take, this one will get oxidized and I will get a compound like this, benzoic acid, right? On oxidation with chromic acid, we get C7H6O2. So 6 carbon here, then 1, 2, 3, 4, 5, 6 hydrogen, and then C7H6O2. Just a minute. Yeah, C7. Then we have 1, 2, 3, 4, 5, 6. 6 oxygen, 6 hydrogen, and 2 oxygen. Identify the compounds X and Y. So Y is it? Y is your what? Benzoic acid, right? And X is what? Acetophenol. okay, and write all the reactions involved. So 3 reactions, 3 marks, 2 compounds you have identified, 2 marks, okay. Next, between methanol and ethanol, which will undergo aldol condensation, write the chemical reaction involved in it. Then how do you convert propanol to propane, write the reactions, okay. So this is very simple. Here you can see ethanol is having alpha hydrogen, because you see the structure of methanol is like this, okay, and the structure of ethanol is like this, right. So you can see ethanol is having an alpha carbon, so it is having alpha hydrogen, so that means it will undergo aldol condensation. Next, write the chemical reaction involved in it. So you can just write down. So first of all, okay, so if I have the first one, 11A, so which one will undergo? First I will write ethanol, okay. Next, the product here, if I want to write the product of aldol condensation, so it is like CH3 CHO reacts in presence of OH minus to give me CH2 minus CHO. This one reacts with another CH3 CHO. This one attacks on this carbon, and we get a structure like this: CH3 COH CH2 CHO, and after that H and OH will dehydrated. You can do or take a dehydration, so you will get CH3 CH double bond CHO, okay, 1 2 3 4. So that is the product formed here. How do you convert propanol to propane? This is very simple. So if I have propanol, okay, propanol to propane, propanol to propane, if I convert, you can see this double bond O to H2. It can be through your Clemmensen reduction, so zinc ZnHg HCl, okay, or you can also use what we say mercury, Wolff-Kissner reduction, where you have to use NH2 NH2 KOH in presence of ethylene glycol. Next, write the reaction and the name of the products obtained when acetophenol reacts with sodium hypochlorite. Explain the formation of anhydrides from carboxylic acid with an example. So first of all, carboxylic acid when heated in presence of H2SO4 or P2O5 will give you an anhydride. You can see here 2 ethanoic acids will be taken, here OH and H2O will be removed, and we will get a compound like this. Next, product formed when acetophenol is reacting with sodium hypochlorite, right? So that means this is the structure of acetophenol, and if it is reacting with sodium hypochlorite, that is your haloform reaction. So this bond will break here. This one CH3CO, this one will get converted to a haloform like this, that is this one will be converted to salt of sodium, okay, and then this one will be converted to CHCl3, okay. Now coming to the next chapter, that is amines, okay. This is a very small chapter, but yes, questions from here can be asked. Give the preparation of para-hydroxybenzene or para-azobenzene, so the coupling reaction, 2 of them, anyone can be asked. pKb of aniline, so here mainly you have to think about the basicity questions, okay. This is not basic, that is more basic, less basic, so reasoning questions based on the basicity can be asked definitely, okay. So first of all, pKb of aniline is more than methanamine. Aniline is a aromatic amine, right? The nitrogen lone pair is not available for donation, it is involved in resonance. So whenever the lone pair of nitrogen, you can see here lone pair of aniline, okay, this is involved in resonance in the ring. It is not available for donation, that means basicity is less, so pKb will be higher, okay. So that's all. You can see the answer like this. So first of all, for para-hydroxybenzene, benzene disonium chloride reacts with phenol, in which the phenol molecule at its para position is coupled with the disonium salt, okay, to form para-hydroxyazobenzene. Next, for pKb for aniline, you can see here that there are 2 reasons. First of all, pKb of aniline is quite high because aniline, the NH2 group is attached directly to the benzene ring. It results in the unshared electron pair on nitrogen atom to be in conjugation with the benzene ring. So it is involved in resonance, right? You can see here the lone pair electrons is involved in resonance with the ring. It is not available for donation, right? Available for protonation. Next, what happens if in case, suppose for example, anyhow that it donates the electrons, okay, and that means what, it will get protonated, it will donate a proton to, electrons to H plus, for example. So it will form anilium ion. Now this is suppose base, then this one is the conjugate acid. So whether this one is more stable or this one is more stable. If conjugate acid is more stable, then it is a strong base, but if it is a less stable, then it is a weak base. So if I see here, you can see a lot of resonating structures, almost 5 resonating structures. Here we have only 2 resonating structures. So definitely this is less stable. If conjugate acid is less stable, that means it is a weaker base. Okay, so you can see here the conjugate acid formed anilium ion has only 2 resonating structures, whereas the aniline, the original aniline, has 5 resonating structures. Therefore aniline is more stable than anilium. So that is why, if this is already stable, why would it form this one, right? So that is why it won't donate or it won't participate in the base. Next, write the general equation involved in Gabriel thalamide. This is a must question, so please prepare it thoroughly. Explain carbyl amine reaction. This is also important question. Arrange the following compounds in the increasing order of their basicity. Okay, so because of space, first I will do B and C, then we will see A. Okay, so you can see here aliphatic and aromatic primary amines on heating with chloroform and ethanolic acid, that is CHCl3 and alcohol. It forms isocyanide, that is RNC, and this isocyanide has a foul smelling cell and it is used as a test for your primary amines. So you can see RNH2 plus CHCl3 plus KOH. Okay, this two will convert this one to RNC, which is your isocyanide, and this gives you a foul smell. Then you have byproduct KCl and water. So that is not important, but this is your carbyl amine reaction. Next, in the increasing order of their basicity, so always you see whenever we have a aryl amine, the basicity will be least one. Okay, so this one will be least. Now here CH3 is there, it is a donating group, it will donate electrons to the nitrogen. The electron density on the nitrogen will be higher. If that is higher, then what will happen? It can donate electrons better, so its basicity will be the highest. So 1, 2, 3 means this is the highest, this is middle, this is the lowest. You can see the order like this. Okay, okay. Next we have here Gabriel thalamide synthesis. It is direct question, there is nothing to be explained here. So thalamide on treatment with ethanolic KOH forms a potassium salt of thalamide, the first step, which on heating with alkyl halide forms followed by alkaline hydrolysis forms your primary amines. Okay, so please practice this one again and again. This is very important question. Please write it at least 5 to 6 times and practice it. Next, what is Hinsberg reagent? How do you distinguish between primary, secondary and tertiary amines using Hinsberg reagent? Very important question. Hoffman bromamide degradation, and give an example. Give the IUPAC, okay, by taking butanamide as an example, and give the IUPAC name of the product. Okay, so I am giving you a general example. So whenever amides on heated are on presence, whenever amides are heated with bromine and aqueous NaOH, it gives you primary amines. The reaction is called as hydroboration oxidation reaction. Now the question has asked you to take butanamide as an example. So we will take butanamide as an example, that is CH3, CH2, CH2, CO, NH2. This is butanamide. When I am treating it with Br2 and KOH, what will happen? This group will be removed and I will get CH3, CH2, CH2, NH2. That is your propanamine. Okay, next Hinsberg reagent. Okay, so you can see here that benzene sulfonyl chloride C6H5SO2Cl is known as Hinsberg reagent, and it is treated with primary and secondary amines to form sulfonamides. Now what happens is, when primary amines react with Hinsberg reagent to form N-alkyl benzene sulfonamide, it is soluble in water, it is soluble in alkali due to the presence of this acidic hydrogen. Okay. Next, secondary amines react with Hinsberg reagent to form NN dialkyl benzene sulfonamide, that is NN dialkyl benzene sulfonamide, which is insoluble in alkali due to the absence of acidic hydrogen. Okay, there is no acidic hydrogen, so it is insoluble. And the next one is tertiary amines does not react. So in this way you can segregate primary, secondary and tertiary amines. Next, an aromatic compound A having on treatment with aqueous ammonia and heating forms a compound B. Okay, so if I have one compound A, it on heating with NH3 gives a compound B. Okay, now which on heating with Br2 and KOH gives you C? If I heat it with Br2 and KOH, so that is your Hofmann bromamide degradation, gives you C of molecular formula C6H7NH2. Write the structure and the IUPAC name of the compounds A, B and C. So if you see here, C6H7, this is nothing but NH2. If this is NH2, then this must be CONH2. If this is CONH2, then this must be your benzoic acid. Okay, so A is benzoic acid, right? Then B is your benzamide, benzoic acid, benzamide, and this one is your aniline. Okay. Next, coming to give reason, during the reduction of nitro compounds, scrap iron is used. So generally what happens when nitro compounds are reduced to amines, you can take SnHCl or FeHCl. So we generally prefer Fe. Okay, what is the reason for that? We have to ask, the question is asked. Then solubility of the aliphatic primary amines decreases with the increase in the molar mass. So this is very simple. Whenever the hydrocarbon part increases, okay, its a tendency to form hydrogen bonding decreases, and as a result of which the solubility will decrease, right? So you can see here, yes. Now reduction with iron and scrap and HCl is preferred because FeCl2 formed gets hydrolyzed to release the HCl during the reaction. So when you are taking this one RNO2, okay, plus FeHCl, you get RNH2 plus FeCl2. Okay, now this FeCl2 further undergoes hydrolysis to give you back HCl, right, which is required here. So now because with very little amount of HCl you can produce more and more amount of HCl, so this is the preferred method. This FeCl2 which undergoes hydrolysis and gives you back HCl, so that is why we prefer this method. Next, solubility. Due to the increase in the size of the hydrophobic part, the solubility will decrease because the tendency to form hydrogen bond also decreases. Next, we have here question number 5. How do you convert nitrobenzene to aniline? Write the equation. So this is very simple. Nitrobenzene to aniline, just you have to use H2 palladium, you can use FeHCl, or you can even use SnHCl. So you have to just mention nitrobenzene is reduced to aniline by passing hydrogen gas in the presence of finely divided nickel, palladium or platinum, or if you are using FeHCl, you have to mention that. Next, how nitriles are reduced to amines? Write the general equation. So reduction of nitriles to primary amines is using lithium aluminium hydride. So what will be the general equation here? We have RCN plus lithium aluminium hydride gives me RCH2 NH2. Okay. Next, how are amides reduced to amines? Write the general equation. So yes, for amides also we have the same thing, that is your lithium aluminium hydride. So if we have RCONH2, if I use lithium aluminium hydride, I will get RCH2 NH2. Okay. Next, next is CH3, CH2, CH2, NH2 has a higher boiling point than CH3 whole 3N because okay, the question is actually why. I have already given the answer here also. So you can see here that methylamine CH3NH2 can form hydrogen bonds due to the presence of hydrogen due to the presence of a nitrogen atom bonded to hydrogen atom. Okay, it can form hydrogen bonds. In trimethylamine, that cannot form hydrogen bond because it has no hydrogen directly attached to the nitrogen atom. Okay, so you need a hydrogen should be attached to an electronegative atom to form hydrogen bond, right? But here what happens in triethylamine, if you see the structure, it's already given, right? In trimethylamine, the structure is like this: CH3N, CH3, CH3, right? So there is no hydrogen attached directly to the nitrogen, so that it cannot form hydrogen bonding. But here you can see that hydrogen is directly attached to nitrogen, it can form hydrogen bonding. So if it can form hydrogen bonding, what will happen? The boiling point will be definitely be higher. Okay. Next, an aromatic compound A on treatment with aqueous ammonia and on heating forms compound B, which on heating with Br2KH forms a compound C. Okay, this question I have already discussed, ABC, right? Okay, we'll just discuss this part now. This I have already discussed there. Aliphatic amines of lower molecular mass are soluble in water. Yes, definitely, because of small hydrophobic part, they can easily form hydrogen bond with water. Methylamine is more basic than trimethylamine. Yes, this is important question, very, very important question. Generally, if you see, this is methylamine and this is trimethylamine, right? So if I see that this group, this can donate electrons more and here the electron density will be more, so it should be more basic, but we find that methylamine is always more basic than trimethylamine. So the reason here is the steric hindrance, because of so many bulky groups attached, this N cannot donate the electrons properly. Okay, so let's see the answer here. Yes, low aliphatic amines form strong hydrogen bonding, so that is why they are very easily soluble. And yes, methylamine is more basic than trimethylamine. This is because the 3 methyl groups attached to the nitrogen atom create steric hindrance, making it harder for the nitrogen to donate its lone pair and act as a base, while methylamine has less steric hindrance with only 1 methyl group attached. So here we have lone pair which can be donated easily, and here because of steric hindrance the donation of the lone pair becomes difficult. Okay, so that is why its basicity is decreased. Next, give the IUPAC name of this one. Okay, just a minute, sorry. Okay, so we have give the IUPAC name of CH3 So if I have, that is NN dimethyl, so it is like this. Okay, so it is, oops, sorry, one second, just a minute. Okay, so it is NN okay, so it is NN dimethyl methanamine, NN dimethyl methanamine. Okay, that's the first thing. Name the major product formed in the following conversions when nitrous acid is treated with methylamine. So if nitrous acid is treated with methylamine, the product formed will be methanol. Benzene diazonium chloride is treated with Ki, you will get iodobenzene. Tertiary amines cannot be acylated. Why? So if you see, what is basically acylation, you have RNH2, and if you just treat it with CH3COCl, okay, or any other group, this part is formed like this, RNHCO CH3. Okay, so tertiary amines, see, so what is basically happening, the hydrogen is replaced with an acyl group, right? So now if you have tertiary amines, means this is also R group and this is also R group. So when there is tertiary group, there is no H group present, so tertiary amines cannot be isolated because there is no hydrogen present to replace, right? So that is the reason tertiary amines cannot be acylated, because they lack a replaceable hydrogen atom on the nitrogen atom, right? There is no hydrogen on the nitrogen atom. Why? Because in tertiary amines the structure is like this. If there is no hydrogen atom which is necessary for the formation of an amide bond during the acylation reaction. Okay, so that is why there is no acylation possible in the tertiary amines. Next, para-aminoazobenzene. So we have already seen para-hydroxyazobenzene. Very similar to that is para-aminoazobenzene. Next, we have a question here. An organic compound P with molecular formula C6H7N is treated with acetic anhydride in the presence of pyridine to give compound Q. The compound Q undergoes bromination with bromine and acetic acid to give you substituted amide R. The compound R on acid hydrolysis yields a substituent amine S. Write all the reactions involved. Okay, let us think again. So what is there? We have an organic compound P, okay, with molecular formula C6H7N, okay. After that, it is treated with acetic anhydride in the presence of pyridine to give you compound Q. So when I see this C6H7, I can very well guess that it is nothing but aniline, okay. Next, when it is treated with acetic anhydride in presence of pyridine, so that means CH3CO whole 2O in the presence of pyridine, I will get here this one as NHCOCH3, okay, and this is your compound Q, this is your compound P, okay. The compound Q undergoes bromination with bromine in acetic acid to give you substituted amide R. So if you do bromination, what will happen? This para position bromine will come, so I will get like this NHCOCH3 bromine, okay. So this is your R, okay. Now the compound R on acid hydrolysis yields a substituted amine S. So if you just do acid hydrolysis, what will happen? We will get back this to NH2. NH2Br, okay. Then write all the reactions. You can write down this one. So here we have bromine in acetic acid. So I have bromine in CH3COOH. Clear? So this is the protection of amines that we do. That method is given in this form. Very good question, this one. Ninth, which is more basic among aqueous solutions of aniline and ammonia? Definitely ammonia is more basic. We have already discussed many times that aniline is having what? Aniline is having the lone pair of aniline is involved in resonance. It is not available. Next, why aromatic primary amines cannot be synthesized by Gabriel method? This is also very important question. So see here, the first one, ammonia is more basic than aniline. The lone pair of the electrons on the nitrogen atom of the aniline are involved in resonance with the benzene ring. Hence, the electrons are not easily available for donation. Okay. Next, we have, because here what happens, if you remember Gabriel thalamide, there is one reaction or one step like this where we have this one, okay, this is there. And then you have Rx, okay, this one attacks on this one and we get Nr here, right? But if this is a benzene ring, okay, then you cannot attack this one and X cannot go out. That process will not take place, okay, that is not possible. You need to have here a, this is not, why? Because we have a partial double bond character here, right? So in that case, what happens? Because the aryl halide do not undergo nucleophilic substitution reaction with the anion formed by thalamide. Okay, there is no nucleophilic reaction. This anion which is formed by the thalamide, in there is no nucleophilic reaction possible. Next, question number 10 here. Okay. Among alkyl diazonium salts and arene diazonium salts, which is more stable? Give a reason. So if you see here, arene diazonium salts are, or you can say aromatic diazonium salts will be more stable because they can undergo resonance here, whereas in alkyl diazonium salt it is not possible because you can show the resonating structures. Here a bond is there, you get a double bond here, this bond shifts here. So like this, a continuous resonating structures are possible. Okay, so first of all, you can see, let me explain this resonating structures. So first bond shifts here, okay, you get a double bond here and this bond comes here, so we get a negative charge here. After that, this bond shifts here, so we get this bond shifts here and we get a positive charge here, okay, and then after that this bond shifts here and we get a positive charge here, and after that this bond shifts here, this bond comes back and we get a structure like this, okay. Dispersal of charge is not possible in aliphatic diazonium salt. Aliphatic diazonium salt, it will be like this, R, okay. So because it is not possible to have any resonance here, so it is less stable. Now the reaction is carried out in the presence of a, okay, here what is the role of pyridine during the acylation reaction of amine. So when you do acylation, we use pyridine. The reaction is carried out in the presence of a stronger base than amine like pyridine, which removes the HCl so formed and shifts the equilibrium to the right hand side. So if you see the reaction, see what generally happens, you have RNH2, okay, and then we have CH3COCl. So what basically happens here is we get like this RN, and here we have COCH3, right, then this H is there, then this H and this Cl can form a HCl, okay. Now what happens, if you see, this reaction can get reverse, okay, this reaction can happen again in this direction to give you this one. So what the pyridine does, pyridine removes this HCl that is formed continuously, so this is an irreversible reaction, okay. So pyridine continuously removes this HCl so that the reaction can proceed in the forward direction, okay. Tertiary amines cannot be acylated, I have already discussed, because it doesn't have an hydrogen, okay. Next, last chapter, biomolecules, some very important questions from biomolecules. So especially first one, what does the tertiary structure of the proteins represent? Writes to molecular major shapes, and write a reaction to show that glucose contains 5 OH groups. Write the Zwitter ion structure of glycine, okay. So tertiary structure of protein is what? When the secondary structure undergoes further folding, that is called tertiary structure. Next, what are its shapes? You have fibrous proteins and globular proteins as the two major molecular shapes here. Next, write a reaction to show that glucose contains 5 OH groups. So you can react glucose with acetic anhydride, okay. Glucose on acetylation with acetic anhydride gives you glucose pentaacetate, which confirms the presence of 5 OH groups in the glucose molecule. Next, the Zwitter ion structure of glycine. So just a minute, okay. So glycine structure, Zwitter ion, you can see. First of all, let me tell you what's the structure of this one. So you have COOH, you have NH2, you have R, and here you have H, okay. Now what happens, there is an exchange, this is COO minus, this is NH3 plus, and here I have, okay, sorry, don't have to remove this H. So this is the structure of a Zwitter ion. In aqueous solution, the COH group donates a proton and the amino group accepts a proton, giving rise to a dipolar ion known as Zwitter ion, okay. Next, question number 2 here, what is peptide bond and how many peptide bonds are present in a pentapeptide? So generally proteins are the polymers of alpha amino acids and they are connected to each other by peptide bond, okay. Proteins are the polymers of amino acids and these amino acids are connected by peptide bond, right. That is your peptide bond. How it is formed? Chemically, a peptide linkage is an amide formed between COH group and the NH2 group, okay. Next, you have how many bonds will be there in a pentapeptide? Pentapeptide means you have 5 amino acids, okay. So in 5 amino acids there will be 4 peptide bonds or 4 peptide bonds. So if you here you can also show how this peptide bond is formed. So I have, like, for example, NH2, okay, C R H double bond O OH. I have NH2 CR H COOH. So now here what will happen? You will have H2O will be removed and you will get NH2 CRH. Then I have C double bond O NH CRH, and then I have COOH group, okay. So this is what an amide formation is there, okay. Amide bond formation takes place in this way. Next, Harvard structure of maltose. So please, I know this will take a little bit of time, so please prepare properly, take your time, at least draw 5 to 10 times the 3 structures, that is your sucrose, maltose and lactose. Very important question. Any one of the structure will definitely be asked. Name the protein present in hair, that is your keratin. Okay. Now coming to what are reducing sugars, give example, name the naturally occurring optically active, inactive amino acid, name any one vitamin that is stored in liver and adipose tissue. So reducing sugars are those sugars which can be reacted or which can reduce your tolerance reagent and Felling's reagent. Example, all the monosaccharides are your reducing sugars. You have lactose and maltose are also your reducing sugars, where you should have a free aldehyde group. Okay, so examples are there. Reducing sugar definition, name the naturally occurring optically inactive amino acid, that is your lysine. Then the vitamin which is stored in adipose tissue, so you can tell vitamin, fat soluble vitamins, that is A, D, E and K. Okay. Next we have question number 4. What are anomers? Give the structures of anomers of glucose. Then limitations of the open chain structure of glucose. So what are anomers exactly? So anomers are the sugars which differ in their configuration at C1 position is called as anomers. And you can see 2 structures of anomers. This is beta D glucopyranose, this is alpha D glucopyranose. Alpha D OH will be present at the bottom, in beta the OH will be present at the top. Next, limitations of the open chain structure. So glucose, it contains an aldehyde group, and glucose, although it contains an aldehyde group, it will not give you positive Skiff test. Okay, and also do not react with NaHSO3. So these are the first limitation. Second limitation, the pentaacetyl derivative of glucose does not react with hydroxylamine, indicating the absence of a free aldehyde groups. Okay. Next we have here that it exists in 2 forms, that is alpha and beta form. So once again let us revise. The open chain structure cannot react with NaHSO3 and cannot react with Skiff's test. The second limitation is the pentaacetyl derivative of the glucose cannot react with hydroxylamine, indicating that it does not have a free aldehyde group. And the third point is it exists in 2 forms, that is alpha form and beta form. Okay. Now we'll have the Harvard structure of lactose. I have already done for maltose. You can see for now lactose. What is denaturation? Example of a water soluble protein. So yes, first of all, lactose structure, again this also please see it carefully, practice it at least 5 to 10 times. Very important diagram. You can see how in lactose there is a zigzag bond is present. Okay, so just remember this structure. Next, denaturation of protein, whenever the protein loses its biological activity due to the change in the pH or due to the presence of salt, it is called as denaturation. During the denaturation, the primary structure is intact. Okay, the primary structure is not affected. Next we have example for water soluble proteins. It is your albumin. Albumin is a water soluble protein which is, or any fibrous protein example you can write down here. Okay. Next we have what are essential amino acids and differences between RNA and DNA. So those amino acids which cannot be produced in the human body, it has to be taken from the diet. Such type of amino acids are called as essential amino acids. Okay, so you have to write that. Yes, any example you can write down, lysine, valine, leucine, any example. There are 9 essential amino acids, so please remember all of them. It will be very useful. Difference between RNA and DNA, this is double stranded, single stranded. It is used in protein synthesis, it is used in storing the heredity of the information or genetic information. Next we can also differentiate between the structures. So sugar present in DNA is deoxyribose sugar, and here the sugar present is only ribose sugar. Okay. Next here the bases are adenine, guanine, thymine and cytosine, and here we have adenine, guanine, uracil and cytosine. Okay. Next we have here 7th one, what are oxidoreductase enzymes? Name the enzyme that catalyzes. the hydrolysis of maltose into glucose. Okay, next give any one main natural resource of vitamin K. Give reason that sucrose is a non-reducing sugar and what is an invert sugar. So first let me talk about this invert sugar. This is very important. See, initially sucrose is there, okay. Sucrose is made up of glucose and fructose, right? So when sucrose is a optically active compound and it rotates the light in the plus direction, means in the clockwise direction, okay. It was dextrorotatory. Now when the sugar undergo hydrolysis, it produces glucose plus fructose, okay. Fructose is levorotatory and glucose is dextrorotatory, but the happens what is the levorotatory of fructose is more than the dextrorotatory of glucose. So overall, suppose initially the light was passing, it was initially rotating in the clockwise direction, but as the time passed, as more amount of fructose formed, it started rotating in the anti-clockwise direction. So there is an inversion of the light or the inversion of the direction of the rotation of light. So this mixture is called as a invert sugar, okay. I hope this is clear now. Let us see the question. Oh, sorry. Yes. So what is oxidoreductase enzyme? So those enzymes which help in the oxidation and reduction simultaneously are called as oxidoreductase enzymes. You can see the enzymes which catalyze the oxidation of one substrate with simultaneous reduction of the another substrate are named as oxidoreductase enzyme. Next, which enzyme is used for the maltose hydrolysis? So it is maltase. It is very easy to guess. The enzyme names are generally named after the substrate on which they act. Next, source of vitamin K is your green leafy vegetables. Give reason. Sucrose is not a reducing sugar, because you can see sucrose does not have a free aldehyde group and hence it cannot reduce the Tollens reagent and Fellings reagent, so it is a non-reducing sugar. Then we have what is an invert sugar. So see, sucrose is dextrorotatory, means it rotates clockwise direction, but after hydrolysis, hydrolysis gives dextrorotatory glucose and levorotatory fructose. The two products, glucose is dextrorotatory and fructose is levorotatory. Now since the levorrotation of fructose is minus 92.4 and is more than the dextrorotation of glucose, which is plus 52.5, the mixture is levorotatory now. Overall, the mixture is now levorotatory. Thus, hydrolysis of sucrose brings about a change in the sign of the rotation from dextro to levo. So originally it was dextro and now it became levo. So there is a change in sign and the product is named as invert sugar. Okay. Next, question number 8 is name the storage polysaccharide present in plants. So that is your starch. Name the monomer units present in starch, that is also alpha D glucose units. Name the components of the starch, that is your amylose and pectin. Differentiate between the components of amylose and pectin. So amylose is water soluble, water insoluble. Here 15 to 20%, here it is 80 to 85%. Here it is a straight chain, here it is a branched chain. The straight chain, here the linkage is between C1, C4, and in the amylose it is C1, C4 and C1, C6 linkage. Okay, the branching or the linear chain goes from C1 to C4 and the branching occurs at C1, C6. Okay. Now we have question number 9 here. Give two methods of preparation of glucose. How to show that glucose contains 6 carbon, it contains an aldehyde group, it contains 5 OH groups. Okay, so first of all, two methods of preparation of glucose. One is from the sucrose, the hydrolysis of sucrose, but the more commercial method where we can get more amount of glucose is the hydrolysis of your starch. Okay, by the boiling starch and the dilute H2SO4 at 390. So you don't have to write these many values, you can just write down from sucrose the reaction, from starch the reaction. Okay, clear? Next we will see this reactions of glucose, that it contains 6 carbons. So you have to react with Hi and red phosphorus, then glucose gives you N-hexane, a straight chain of 6 carbons. This tells that glucose has 6 carbons in one chain. Next, for aldehyde group, what we have to do? For aldehyde group, it reacts with acetic anhydride and gives you glucose pentaacetate, and this tells you that there are 5 OH groups. This we have already discussed. For aldehyde group, this one is the reaction. Okay, so this has to be yeah, this is 3 and this is 2. Okay, so there is some order, please check it properly. This one is this one and this one is this one. Okay, next, yes, so if you treat glucose with bromine water, okay, now see, bromine water is a very mild oxidizing agent. If any aldehyde is present, then that will get converted to acid. So what was observed is when glucose was treated with a mild oxidizing agent like bromine water, it gave you gluconic acid where there was a COH group. Now this confirmed that the aldehyde group, the alcohols cannot convert to acids here because it is a mild oxidizing agent. And ketones will also not give you acid. The only thing which can give you an acid with a mild oxidizing agent is your aldehydes. So definitely aldehydes must be present here. So that is the reaction done. Okay, next we have explained the preparation of glycyl ananyl with equation. What is meant by glycosidic linkage, what is linked by peptide linkage. Okay, so this we will do first one. Before that, let's study the other 2 questions. Glycosidic linkage, the 2 monosaccharides are joined together by an oxide linkage formed by the loss of water molecule. Such a linkage between the 2 monosaccharide units through oxygen is called as glycosidic linkage. Then what is peptide linkage? The CONH bond between 2 amino acids is called as peptide linkage formed with the loss of water molecule. Okay, peptide linkage is between 2 amides group, or you can say between 2 amino acid by the loss of water, and that will give you this CONH group. Okay, next we can see the, yes, one second, preparation of glycyl aniline with this equation. So I have GLY, that is your, this one is one amino acid and you have alanine, another amino acid. Okay, so I can write like this, that is CH3. Okay, not like this, sorry. Let me take here. Okay, so suppose we have NH2. Okay, then I have C, I have H, I have H, then I have C double bond O, OH, then I have NH2, CH double bond CH3. Okay, so here what will happen? Yes, so here one H2O will be removed. Okay, I think something, yeah, this is there. So now what will happen? Now you will get NH2, CH2, C double bond O, NH, C, CH3, COOH. Okay, clear? Next, yes, this I have discussed. So this is the this is what you can say, the peptide bond formation between the glycyl and the alanine, glycine and alanine. Okay, okay, now functions of carbohydrates and reducing sugars we have already discussed. Functions of carbohydrates I think all of you will be knowing, but still in the exam you may not remember, so quickly have a glance here. Cell wall of bacteria and plants is made up of carbohydrates. It is a major portion of our food. Carbohydrates are used as storage molecules in as starch in plants and glycogen in animals. Okay, so the energy currency, or you can say the energy that we get is from our carbohydrates. Reducing sugars we have already discussed. Okay, yes, this is very important table that I have drawn for you. What you have here different sugars, you have their monomer units, and here you have their linkages. So these questions can be asked, what are the monomer units of different disaccharides. So please draw this table, take a screenshot of this and prepare it properly, and remember the monomer units of each of them and what is the linkage, which carbon to which carbon there is a bond. Next, Yes, hormones. So the functions of hormones are very important. The vitamins deficiency disease, that is directly given in the table, so please refer to that. Hormones, it is given in a big paragraph, 2 pages of paragraphs are there, so I have converted into tabular form so that you can learn it easily. Okay, so first of all, how many types of hormones we have? Polypeptides, amino acid derivatives and steroids. So in polypeptides we have insulin, endomorphin and glucagons. Amino acid derivatives we have epinephrine, norepinephrine and thyroxine, and steroids we have estrogens and androgens. Next, coming to the functions. So glucagon and insulin together maintains the sugar level. Epinephrine and norepinephrine responds to external stimuli. This has been asked in the question before also. Thyroxine, it is produced in thyroid gland. It is the iodinated derivative of amino acid tyrosine. Then low concentration causes hypothyroidism and high concentration causes hyperthyroidism. Okay, then we have here steroid hormones. You can see steroid hormones are also, that is produced by cortex and adrenal cortex and gonads. So here are glucocorticoids, mineral corticoids, which are produced by adrenal cortex. Okay, so it is released by adrenal cortex, and then you have here they control the carbohydrate mechanism, inflammatory, so you can read this. And mineral corticoids maintains the level of excretion. Here one disease is also there, addition disease. It is caused when your mineral or adrenal cortex is not functioning properly. That means mineral corticoids will not be produced properly, and you can find problems like hypoglycemia, weakness and increased susceptibility to stress. Then we have next one, that is your some what I can say sex hormones, that is female and male hormones. So testosterone functions are there, estradiol functions are there, and then progesterone different functions are there. Okay, so with this I want all of you to revise this hormones part properly, and I have completed all the questions, and I have taken all the questions covered from your PU question bank as well, so you do not have to worry. Please do these questions and complete the name reactions from organic chemistry, then organic chemistry will be ready for your exam. Okay, so please practice, and if you have any doubt please comment down, and many of you have requested to give you the PU question bank, so that I will upload in our WhatsApp channel. Link of the WhatsApp channel will be there in the description section, so you can easily download it from there and practice it. And for MCQs and numericals also the videos will be coming. Please have a bit of patience, you study the way I have given you the study strategy. So today is organic day, please cover all your organic. Tomorrow physical chemistry, you will get questions from your PU question bank, and also all the numericals are done from the PU question bank, and MCQs also I will be doing on Monday, and that also will be taken from the PU question bank. Okay, so please do not worry, all the very best, study calmly, and just if you need any help please let me know. Okay, thank you and all the best.